So those residuals are really the vertical differences between these points and the line. If you calculated how far off they are from the line vertically, that's what the residual means. So some are below the line, some are above. So some are negative, some are positive. So that's the error, residual. Okay, so next thing we want to do is, look at it. How well does it fit the data? That's the next thing besides the R-squared value being close to 1. We just look at the data graphed with the line, the regression line. Does it look like it falls fairly well in between all the points? It's not bad. This one's kind of far off. That one in the middle is a little further off, but in general, it kind of follows the trend. It's not bad. So that's one thing to look at. And also, is it realistic? Would all these different values be realistic? Now, in this case, it's test scores, and what if you got if the model happened to predict like a negative GPA? Does that make any sense? No, right? So you throw out that model if it happened to somewhere, dip down below the x-axis and predict something negative that couldn't be negative, like someone's weight or population of a city, that kind of thing. So that's the third indicator, right? Visually, looking at the data graphed with the line, the R-squared value, and how realistic are the predictions. Now, when you go back to apps, and the next thing we're going to do is the stats list editor. Next thing we want to do is to create a column. Oops. Go back down out of there. Escape. All right. So scroll over there with your left arrow key. And in this third column, I want to create a column where I put the predicted values. I want to know what's happening when I put this x, this 19, score of ACT of 19, into my function. And how close is it to predicting 1.986? So we want to get the predicted values, which is basically y1 of x data, right? Sticking the x data values into y1. So again, we're going to insert another column, and name this one predicted, PRED. We'll call it PRED. So we have alpha locked still. So go down to P. Where are you? P R E D for predicted values. And if you have different models you're trying, you could call one linpred and one of them quadpred, like whatever you want to help to. But we're just going to do the one for right now. So name that one. And then you want to arrow back up so that you're highlighted on PRED and hit enter. We're going to give it now a formula. And basically, to get predicted, what we're doing, and whenever we do a formula, we use this little quote, which is really tiny and blue on the 1 key. So second 1, and it puts a little quote there, which we use whenever we're doing a formula. Okay, we're having it compute. So we're going to have it compute y1, which is where we stored the regression equation, y1, and we're plugging what into y1? We're plugging x data in, right? So we'll pull that from our variables link. So go to the second minus again and hit x, click down to x data, and hit enter. So y1 of x data, and there's your function notation. That means we're plugging all of these different values into that y1 function. And then finish your quote. So second, all right, and enter. And it wants to attach that list formula, that's fine. We can go ahead and attach it to that. So it stores it in our variables link. So now pred will appear in our variables link list if we need to pull it up for predicted. All right, great. So the predicted values. So how are they pretty close to the y data? Looking at them. So according to our model, someone with an ACT score of 19 really has the 1.986 GPA, but this model kind of overestimates, right? It predicts they'd get a 2.05. And with the 21, here's an underestimate, right? From the 2.86, it's predicting 2.6652, and so forth. So just kind of looking over, are they realistic? Yeah, they're fairly close, to the actual values. They're definitely in a normal range of, 0 to 4 that you'd get for possible GPAs. Okay, so there's your predicted values. So now to get the actual errors, and I know there was a column all the way on the right for the residuals, but here's a way you can actually build it so it appears in your table right next to the predicted values, which is sometimes convenient, and just to, go over the programming of it again. So if we want to insert another one, insert, so INS, and we're going to call this column now residual. So we'll just use res, R-E-S. So R-E-S for residual. And then again, you have to arrow back up to actually and enter to give it some kind of a formula, right? And use your quote again. So second, the residual again is going to be the difference between this column and this column. Your actual y coordinates of your points and your predicted values, the y coordinate of the point on the function, on the line. So just that vertical change between them. So we take y data. Again, you can go to your variables link, whoops, which is blue. Whoops. So variables link menu and call up y data. Just down here, have to arrow down. Okay, y data minus the predicted values. And again, I get that also from my variables link menu. And P, I want to go down to my P's. P, because it's still locked on the alpha. So pred for predicted values, and enter, and then finish my formula, right? So second quote, and enter, and attach that one, yes, and it's going to populate. And it just takes, it's like using it like a spreadsheet, like Excel, taking the difference between this column and this column. Okay, so there's how you get your errors. You can use the model then to predict. If you go back to your graph, and let's say we want to predict, okay, if somebody has a GPA of, I don't know if it would have to be within the range of this window right here unless we expand it, but I think so if they have exactly a 2.0 GPA, then predict what their ACT score was, right? So to do that, we could go to y equals, we could say, okay, well, let's say their GPA is 2, right, which is our y value, and enter it, and then look back at the graph. And we can see where, okay, so it's close to that actual data point, right? Right about there. Let's see what their ACT score would have been. And then you can use your intersection, right? So go to F5, and 5 for intersection. Enter the first curve, enter the second. And then the lower bound, of course, we want to get left over here to close to where that intersection is, which is a little bit hard to see because of the point at the bottom. But as long as you're clear of that parabola. Enter, and then the upper bound arrow to the right, enter, and there we go. So it looks like a score of about 18.85 if you have a GPA of 2. So that would be the prediction based on the model. And you can predict the other way around too, right? If you have an ACT score of 25, what will your GPA be, right? And to do that, we just go to the F5 math, and that's just a value, right? We want to know what's the y value, what's the output if x is 25, if I have a 25 on the ACT. And that takes me down, oh, my GPA is about 3.51. Okay, so predictions, and doing regression, looking at residuals. The last thing is a residual plot. I'm going to come back and talk about that a little bit later.